Welcome to the PhotoModeler Scanner tutorial on working with triangulated meshes. We start with an existing solved point cloud of this sand pile. Select the point cloud and choose the Modify Point Mesh tool. These first steps deal with the point data and are covered in the previous tutorial. Step 4 uses the existing point data to create a triangulated mesh. These remaining steps adjust the triangulation in various ways. You can run each step independently or have them run all at once. For example, we could mesh, fill holes, unify normals, but leave off the other settings. If the resulting mesh is not smooth enough, we could select it and run just the smoothing steps. We would then have two triangulated meshes in the project, one without the smoothing steps and one with them. This allows you to compare the results. Or we could take that mesh and just run the decimate step to produce a second mesh with fewer triangles. In this case, we will run step 4 to generate the triangles. If there are noisy or extraneous floating points, set the noise level to high to cause the triangulator to ignore these points. Our point mesh is not particularly noisy, so we can leave the default of medium. Run step 5 to reduce the number of triangles. You could generate a mesh without this step and run it independently to reduce the number of triangles in the mesh while maintaining the surface shape. Changing the percentage will adjust how many triangles are removed. Step 6 to fill in any gaps where the point data is not dense enough for step 4 to fill. Step 7 will make sure that all connected triangles in the mesh face the same direction. Step 8 will fill any edge holes or fjords in the triangulated mesh. We will leave the smoothing steps off but could run them later if we wanted to smooth the data. We'll also turn off contours. We press Execute to run these steps and to triangulate our selected point cloud. The result of our triangulation along with the original selected point cloud can be seen here. We can turn off the point cloud and see just the triangulated mesh. The meshing steps have no way of knowing which way the resulting triangles should face. If your mesh is facing the wrong way, you can select it and use the Flip Mesh command to have it face the opposite direction. Select it and flip it back to the correct direction. Once you have a triangulated mesh, you can optionally create contour lines. For contours to make sense, you need to have your coordinate system defined, either through control points or by setting up a scale, rotate. In this case, we have a scale and rotation set. You can see our z-axis is pointing up. We select our mesh and choose Modify. Uncheck all the previously used steps. We will choose to make a contour line every 5 millimeters along the z-axis. Hit Execute to create the contours. In the 3D view, turn contours on. Contours can be turned on and off independently from the point mesh they represent. You can see the contour lines with our mesh. Turn off the mesh and see just our contour lines. If you select a contour, the contour's height will be displayed on the status bar. To remove an individual contour, you can select it and press Delete. Undo will bring the contour back. In Point Mesh Edit mode, you can select individual segments of an existing contour and remove them by pressing the Delete key. This can be useful if you do not want the contour to be a closed loop. Lastly, you can select an individual point mesh and export its contours. You can save the contours as a text file of comma-delimited polylines, as a 2D DXF file, or as a 3D DXF file. We'll choose 3D DXF and export the file as file contours.dxf. This file can now be used to bring the contours into a CAD or other graphics package. This concludes the tutorial on triangulation. We have shown how to triangulate a point mesh, how to modify the triangulation using the various steps on the Point Mesh Modify dialog, and how to create, view, and edit contours.